Good evening. Good evening, Raj. Is the audio and video is clear to all of you? Audio and video is clear. Try to give the response in the chat box. Audio and video is clear to all of you. Raj. Now, in today's lecture, we are going to concentrate on necessity of velocity triangles. Okay. Now, before that, I will give you a brief introduction regarding me. And all of you, my dear friends, try to like this video, share it, and subscribe the YouTube channel. And this is Balaji Gupta, having 17 plus years experience in teaching, 8 plus years experience in GATE and engineering services examination. Did UG from JNTU and PG from IITM. My expertise subjects are industry engineering, engineering mechanics, fluid mechanics, and drawing. I mentored more than 30,000 plus students in GATE and engineering services point of view. Good evening, Vignesh. Govind, good evening. Salaluddin, good evening. I hope Salaluddin, yesterday you came or not? Okay, Sharmila, Vivek, Seenu, good evening to all of you. Yeah. Now, without much delay, we are going to enter into the subject. Before that, already Vision 3 batch is going on Gradeup channel, and try to enroll into it. And along with me, the following people will guide you in order to crack the GATE and ESE examinations. And Vision 3 batch, batch 3 batch, having the following features. Good evening, Sharvana. Now, it consists of 750 plus live hours and 7,000 plus okay, good. Salvathan, I know you are a regular student of mine. You as well as Sharmila and Vivek and Vignesh, all people are following regularly. Thank you, and give the pass the information to your friends also to follow this particular video. Good. Now, if you have any doubt in this, try to contact Anand Pandey at the rate gradeup.co or contact to his number. You can able to give the exact information to you. Now, before going into velocity triangles, you are already aware of it, where we are going to get these velocity triangles, because whenever the jet impinges on the vane, it is going to exert some force on it. But stationary vanes, you won't observe the thing, but on moving vanes you can able to get it. Before entering into it, I'll give a brief introduction regarding this, because this was already we are already discussed this particular element in the previous videos. If you want, you try to move into that. Force exerted by the jet on a flat and inclined vanes, there we are already come across. So try to look into it, you can able to get some clarity. So here I will give some elements here. So what is this? This is the stationary flat vane. So I am considering it is a fixed one. Then what we are going to consider, if it is a stationary flat plate or flat vane. So the obstacle placed in the path of the jet is called vane. So if it is a stationary flat vane, what is the formula? Force exerted by the jet in the direction of the jet. I am assuming the direction of the jet is x-axis. Therefore, f of x is equal to, you are already aware of it, rho q v, and we can able to write it as rho a v square also. So good evening, Kumari. Now, sir, this is a stationary vane. Sir, once it is a moving vane, how we are going to get it? Let us consider this particular case. This is a moving vane. So, how much force it is going to exert on it? Here, some more points I will give you, try to remember. Here, the force exerted by the jet on the vane, f of x is equal to rho q into v minus u. Here q is not total q, here QE I am writing. For my analysis I am taking QE. What is QE? Effective discharge hit the vane. Effective discharge hit the vane is considered this. So here what is effective discharge, sir? Whenever it is a single vane, QE is considered as A into V minus U. Even though the velocity is of the jet coming out from the nozzle is V, but at the time whenever it is hitting the vane, the velocity is going to be V minus U. Therefore, it is going to becomes rho into A into V minus U whole square. Here, this is the work input, but here efficiency and everything will be there, but up to whatever we required, I am coming across that only. Now, sir, once if it is a single moving vane, is it possible in practically? If this is the vane and this is the jet, so by the time when it hits the plate, it will move to some distance. It will move to some distance, means in order to maintain V minus U as constant, we have to move the jet along with the vane. It is not possible, sir. Then how we can able to get this scenario as constant? With the help of a series of vanes. Whenever it is a moving vane, once it is hit it is going to move with v velocity. If the nozzle is not going to move with a velocity of u, then after some time it will move away, and even though discharge is coming from the nozzle, it won't hit the vane. That's why in order to get this, we are going to use series of vanes. Sir, once it is a series of vanes, how it is going to be? It is going to be like this. So in this case, how we have to consider, sir? How we have to consider? Same thing. F of x is equal to force exerted in the x direction. F of x is equal to rho into q effective into the velocity at which it will hit the vane, that is v minus u. So if you want the derivation of this one, I gave it in the I hope last week I gave this particular explanation. You look into that video, you can able to get some more clarity. Here I am going to explain what is the necessity of velocity of triangles. That's why I want to recall all these information. So here I have a doubt. What is effective discharge, sir? Remember, it is going to be A into V. Remember all of you, my dear friends, whenever it is a single vane, whenever it is a single moving vane, effectively discharge hits the vane is going to be A into V minus U. Once if it is a series of vanes, it is going to be A into V. How it is? I will give some rough example also, don't worry. Like, so here in this case what will happen? F of x is equal to rho into A into V minus U. Remember, this is important, this point is important to you, this thing. So whenever it is a series of vanes, Q we have to consider as A into V. A into V. How, sir? How it is going to be possible? Let us consider this is the vane. On this vane some pocket of fluid is going to hit. Then it will move. Next vane will comes. Again the pocket of fluid will hit this particular vane and it will move. Let us consider, in my case, in this particular example, I am considering Q is going to be 10 centimeter cube per second, 10 units, some 10 units, and velocity of the jet is going to be 10, sorry, okay, not a problem, 10, and vane velocity I am assuming it as 8. Vane velocity I am assuming it as 8. Therefore, sorry, not 8, it is going to be 2. That much it is not possible. I am going to assume it as 2. So how much in the first pocket, in Q1, how much discharge will hit this one? So it is going to be Q into V minus U. 80 units in the first pocket will hit this particular vein. But what about 20, sir? Whatever it is coming in the next vein, it will hit here. 20 in the first pocket will hit this. Sir, what about once if it is comes to it? This is the first vein, sir. This is the second vein. Once the second vein will come here, in the second pocket of the fluid, 80 will hit this, 20 will hit this, 20 will hit the third one. In the fourth one, what will happen? So 80 of the third one will hit this, 20 of the third packet will hit the next vein. Up to this it is clear, my dear friends. So that's why if you observe all the places, here how much discharge will hit it? It is going to be 80 in the current, 20 is due to previous one, totally 100, that is going to be Q into V. Q into V is 100, that one is going to hit this. That's why whenever it is a series of veins, effective discharge hit the vein is going to be considered as A into V, and if it is a single vein, we are going to consider as A into V minus U. This is the point you have to remember. Is this one is clear or not? You tell me. If not, I can able to explain some more elaborately, because this is important. Majority of the textbooks you may observe, sir, whenever it is a single vein, they wrote this formula, sir. If it is a series of veins, they wrote this. Why, sir? Because here Q is the important element. If it is a single vein, we are going to consider as A into V minus U. If it is a series of veins, we are going to consider as A into V. Is it clear, my dear friends? Try to respond, then I can able to move to the next topic. Try to give the information. Good. Can I explain once again in an elaborated fashion, or it is clear for this? This one you try to observe. Effective discharge. Explain once again, Sharmila. Okay, no problem. Let us consider once if it is a series of veins. Why Q is going to be considered as A into V. So if it is a series of veins, Q will be considered as A into V. Why not A into V minus U? Let us consider, I am taking an example. Q is a product of A into V. Okay, sir. But I am considering cross-sectional area. A is going to be in the previous one. I hope it is not Q, sir. It is A. Okay, that's why you may have the confusion. A is equal to 10 centimeter square or meter square it may be, and V is going to be 10. V is going to be 10 and U is going to be 8. Therefore, I am considering the pocket of jet will it hit this particular vein. Once if it is moves, next fluid pocket particle will hit this. Yeah, okay, I will give, because this type of explanation you can't able to get it in the textbooks. But then you observe this equation only. Why we got, we have to know. So first pocket will hit the first vein, it will move. Second vein will comes into the picture. Again, second pocket of fluid will hit the vein and it will move. And third pocket will hit the third vein, like that. Let us consider whenever the first pocket, I am assuming this is my first vein, second vein, third vein, fourth vein, like this. First vein, what happened is, due to A into V minus U, what happened? 80 units in the first pocket will hit this. But what happened to the 20, sir? Here if you observe, so even though if it before coming into it, some part of the discharge will hit this. Therefore, this is going to be 20 A into U. So A into V minus U in the current. In the next pocket, it is going to be A into U. Therefore, what will happen? This is in the next first pocket, in the second vein, first pocket 20% will hit the this vein. So what about the second pocket of the fluid, sir? In the second pocket, A into V will hit this, 20 in the second pocket will hit the third vein. Similarly, fourth one if you consider, so third pocket of fluid, 80 of the third pocket of the fluid will hit the third vein, and 20 of the third pocket of the fluid will hit the fourth vein. Similarly, what about the other one? Fourth pocket, 80 will hit in the current vein, 20 will hit the next vein. Like this it is goes on continuous. Then now tell me, now here if you observe on except first, in the here how much quantity it is hits? 100. 20 from the previous, 80 from the current, totally it is 100. Everywhere it is 100. So here if you observe how we can able to get 100, that is nothing but Q is equal to, so Q effective is equal to Q A into V minus U of current pocket plus A into U of previous thing. Totally if you consider, QE is equal to A into V. QE is equal to A into V. Up to this it is clear, Sharmila and other people? Just you respond, then I can able to move to the next element. Is it clear, my dear friends? Now you try to give the response, I can able to have the idea. Yeah, just now you gave the thing. Okay, Vignesh. Now, Sharmila, is it clear to you? Okay. Now, we'll go ahead with the next one, sir. Sir, once if it is a flat vein is okay. Good, good. Thank you. Very good participation. Next, if it is a inclined vein, inclined vein. Thank you, Vivek. Once if you ask more and more, they can able to give more information to you. Let us consider if it is a inclined vein. You are already aware of it. So inclined stationary vein as well as inclined curved vein. Sorry, inclined stationary and inclined moving veins will be there. So here one is I am going to consider inclined, this one and this both are there. Now let us consider in this case how much is the forces. I hope if you remember these things, f of x is going to be, actually I got it from f of n. If you go through that particular video, you can able to get the clarity. Rho a v square into sine theta, and f of x is equal to rho a v square sine square theta, and f of y is equal to rho a v square by 2 into sine 2 theta. I hope I gave these two to you. Apart from these, one more information I gave. Here the discharge is Q1, here the discharge is Q2. Therefore, Q1 is equal to 1 plus cos theta into Q divided by 2. Q2 is equal to Q by 2 into 1 minus cos theta. The derivation is also given in the previous one. Just to look into it, you can able to get the idea. Sir, once if it is a moving vein, if it is a moving single vein, first of all we will go ahead, then we will go ahead with the series of veins where it will changes. So once it is a single vein, then moving vein also we will consider. So once it is a single moving, then where it will changes, sir? F of x is going to be, f of x is going to be rho a into v minus u whole square into sine square theta. Same, sir. In place of v square, I have to write v minus u whole square. F of y is equal to rho a v minus u whole square by 2 into sine 2 theta. Okay, sir. If it is a series, of veins, what we are going to consider, same, that is f of x is going to be rho A V into V minus U into sine square theta. F of y is equal to rho A V into V minus U by 2 into sine 2 theta. So you remember all these things. Later I will explain where the necessity will come. I will explain to you. Now this is about inclined vane. Sir, if it is a curved vane, then how I have to find out? I will give for single moving, means stationary, single moving and series of moving also. So once if it is going to be like this, so here I am going to consider unsymmetric. So whenever phi 1 is not equal to phi 2, then it is called unsymmetric. So what is that? If phi 1 is not equal to phi 2, then it is called unsymmetric. Here the jet is enters at center. All of you try to understand this concept. This is most important. It is enters at the center. Sir, not only at the center, there is a possibility of entering at the tip also. Here if you observe, here it is not considering at the center, it is going to be enter at one tip and leaving at other tip. Same when you may assume. Sir, but why you are considered as phi 1, phi 2 here, theta comma phi here? Anyone can able to give the answer for this? Sir, why you are considered phi 1, phi 2 here, whereas here you are considered theta comma phi? This is also unsymmetrical, remember my dear friends. This is also unsymmetrical, this is also unsymmetrical. It is enters at the center. If it is enters at the tip, it enters at tip, this is going to be the way. Then how to find? I will give f of x and all those things. First of all, you tell me why I was consider phi 1, phi 2 here, theta comma phi here. Anyone can able to give the answer for this? Try to give. Anyone? Can you be able to give the answer for this? So the answer is very simple, sir. Wherever jet enters, that is considered as theta. Good. Theta may be nozzle inclination. Remember my dear friends, here theta and phi are not related to the nozzle. These symbols are most important. Theta and phi are not related to the nozzle. They are related to the vanes. They are related to the vanes. Sometimes nozzle inclination will be the same as vane inclination. Sometimes it may not. It may not. Then how we have to consider them? Any other? Anyone? Good try, Salaluddin, but we have to know the exact one. Any other can able to try? What is the exact meaning of it? Why it is? So it is based on jet and the vane, that at the tip of the vane, whether the jet is entering or leaving. Whether the jet is entering or leaving. The tip at which jet enters into the vane, tip at which jet enters is called theta. Wherever it leaves or exit can be considered as phi. Govindraj, phi for blade angle and theta for jet angle. No. Govind, there is a small error, my dear. Just you observe. Theta and phi. So let us consider there is a vane, sir. there is a vane like this, there is a vane like this, and if it is having the edges will have the, if you draw the tangents, here it is having two inclinations, here it is having two inclinations. If the inclinations both are called Vane angles only, these two are called Vane angles, but the symbol is going to provide to these based on the jet enters or leaves, jet enters or leaves. Do this. This channel is meant for GATE, ESE, PSU's examination, but this topic will be useful for SSC and RRB exams and JEE exam also. Okay, friends. Now, here, if you remember, here these two angles, Vane will have two angles. So, but the angle symbols we won't give. It depends on the situation. I am going to draw few things, sir. If it is if I consider a black, if the jet enters like this, then it is going to be theta, and wherever it leaves, this is going to be considered as phi. No, sir. If the jet enters here, then this angle will become theta. It is going to leave, so it will become phi. No, sir. If the jet is going to be behaves like this, if the jet is going to enters like this and leaves here, the leaving at both the tips, therefore both are going to be considered as phi, both are considered as phi. Is it clear to all of you? So both are theta comma phi are Vane angles, theta comma phi are Vane angles. If the jet is going to enter at what the tip at which it is entering, it is called theta, and phi is leaving angle. So theta comma phi are Vane inclinations, Vane inclinations. Remember one thing, this is important. Theta comma phi are called Vane inclination. Which Vane, sir? Most important, remember. This is going to be considered as guide vane. Guide vane inclinations. Guide vane inclinations are theta comma phi. So if the jet enters at the center, both the places jet is going to leave. Therefore, both are considered as phi. Therefore, in order to differentiate, I am going to give it as phi 1 and phi 2. But whereas here it is enters here and leaves here, that's why we are going to consider as my dear friends, if you remember here, these formulas I was not derived, but I am going to give the direct answer, but later I will give the thing. So if the jet is entering with a velocity of v and leaves from here, then what will happen is f of x is equal to, if it is unsymmetrical, and symmetrical. In symmetrical, again I will consider single and series. Single and series. Now we will go ahead with what is f of x and all those things. So I am going to write what is f of x. What is f of x in this case is equal to rho a v square into 1 plus cos phi 1 plus cos phi 2 by 2. So divided by 2 is valid only for this portion. Divided by 2 is valid for this portion. So if it is a series, what I have to do? Here it is going to become, I am going to use another color. Single means f of x is equal to rho a v minus u whole square into 1 plus cos phi 1 plus cos phi 2 by 2. But once it is a series of vanes, because I am writing here for this, f of x is going to be rho a v into v minus u into, as it is whatever I wrote here, 1 plus cos phi 1 plus cos phi 2 by 2. Because in place of, in this case, q is equal to a into v. In this case, q is equal to v a into v minus u. In this case, you are already aware of it, q is equal to a into v. That's why you wrote q as a into v. If it is a stationary, I will consider impact velocity is v. If it is moving, the impact velocity is v minus u. That is only the difference. Sir, once it is a symmetrical, what about the second? If it is a symmetrical, then what will happen? We are going to get f of x is equal to rho a v square into 1 plus cos phi. So I am assuming phi 1 is equal to phi 2 is equal to phi. Then we are going to get it here. Then what about these two formulas, sir? Rho a v minus u whole square into 1 plus cos phi. What about in this rho a v into v minus u into 1 plus cos phi? Is it clear, my dear friends? Now I will come. You may ask the questions after my explanation. Just you observe this, because your velocity triangles necessity will enter into the picture. So once it is enters at the tip, once if it is enters at the tip, this is the diagram. So what we are going to consider, it is going to be stationary, and next one is moving, and here it is going to be single and series. Now if you observe here, f of x is going to be rho a v square into cos theta plus cos phi. Here I hope you know already answer. A rho a v square v minus u whole square into cos theta plus cos phi. For this, rho a v into v minus u into cos theta plus cos phi. Is it clear? Just you observe, is it right or not? Just you tell me, anyone. Sir, here I gave so many formulas. In this sheet I gave the formulas. In this sheet also I gave the formulas. But is they are correct or not? If it is stationary. If it is symmetrical means, so another one also I will write. Let us consider theta is equal to phi. Theta is equal to phi. And I am assuming this is equal to some gamma. Not necessary, just you assume theta only. Then what it is happen? 2 is going to comes outside. 2 is going to get outside. So up to this it is clear. Is there any mistake in this particular formulas? Is there any mistake in these formulas, or this is okay to you? Which angle will give the more efficient? I will give the, my dear friend. If it is enters at the tip, it is more, or it is the enters at the exit, it is tip is more. So my question for you is, force exerted is more when it is enters at center or at tip? When it enters at tip or at center? This is your question. Later you try to give it. Now from that your answer you will get, Mr. Ravan Asra. You can able to get the answer for that. Good. Now, sir, in this anybody have the doubt? Anybody is having the doubt in this, or it is clear? It's clear, or it is anybody is having the doubt? Try to give it, because from this only you can able to get an important element. You can able to get important element. Enters at tip. Uh, with examples you consider theta comma phi, two angles you consider and substitute them, you can able to get the clarity. You can able to get the clarity. Enters at the tip. Okay, okay. You both the people gave the answer as enters at the tip. After that, you try to check it out. Thank you, Avinash. Akarsh, others. And anyone? Okay. This one you give it later. Up to this, it is clear. But remember, my dear friends, whatever I am going to round off, this is wrong and this is also wrong. These two are wrong. Similarly, in this, whatever the formulas I wrote in this portion, it is going to be wrong. But whereas in this case it is correct, sir. In this case it is correct, and in this case also it is correct. Anyone can able to give what is the answer what is the answer behind them? Jet center, because jet enters more. No, 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 not that is the reason. Very simple, my dear friend. You take theta is equal to any value, phi is equal to any value in this case. So in the previous last video, it will become phi 1, it will become phi 2. Some angles you consider. It may be some 15 degrees. Here it is 20 degrees, you may consider unsymmetrical. Then you check it out. Then you check it out. You will get definitely more at center. Definitely more value at center than the tip. Center is going to get more than the tip. Try to analyze that. Try to observe it. You will definitely get that. Okay, just you check it out. Okay. So answer is when it enters at the center, it will be more as compared with enters at the tip. Okay. Sir, why you are crossed these two? Anyone can able to give the reason? Why you are crossed these two, sir? You said these two are wrong, sir, and these are also wrong. Why, sir? Why it is in moving? Sorry, it is not. In case of moving, why you can able to consider they are wrong? Anyone can able to guess what is the answer behind it? What is the answer behind it? Anyone can able to guess? Whereas if you consider one more, sir, double hemispherical I am going to give. Double hemispherical. So if it is a stationary and another one is moving, here again single is there, single and series. So here the formulas are f of x is equal to 2 rho a v square. Here it is going to be 2 rho a into v minus u whole square, 2 rho a v into v minus u. If it is enters at the tip, this is the formula for enters at tip as well as center. Both you will get the same. So if the time permits, on some other day I will detailedly explain how we can able to get all these things. But here you remember, my dear friends, in this case these two are correct, but in the previous case these are wrong. Why, sir? If it is enters at the center itself, you said for moving vanes we should not consider this. If it is enters at the tip also, you are not going to consider it. Is there any particular reason behind it? Anybody got the doubt in your undergraduations? Sir, in the class you got the doubt why you are going to enter into the velocity triangles? Once if it is if it is not a curved or if it is a flat vane, we will consider these formulas as it is. If it is a flat vane, we are accepting this formula and this formula. But once if it is a curved veins, why you are not going to accept this? Anyone can able to give it? If you don't know, I can able to give the answer. Just you try to give the answer if you know it or not. Anyone? Anyone? Try. If you don't know, I can able to explain. It is a very simple thing. No, not because of symmetry. Because here, if you observe, my dear friend, in unsymmetrical I make it as wrong, in symmetrical also I make it as wrong. This is belongs to unsymmetrical, it is belongs to symmetrical, both I mentioned wrong. In the next one also, unsymmetrical it is wrong, symmetrical also it is wrong, symmetrical is also is wrong. Anyone can able to try, because once if you think the subject in this fashion, then only you will get the answer. No, I said even though theta comma phi, here what I will write is f of x, I will write it as 2 rho a v square cos theta. This is right, boss. But whereas you are going to, if you write it as 2 rho a v minus u whole square into cos theta, in this case 2 rho a into v minus u cos theta. So in this case, this one is wrong and this one is also wrong. If it is a symmetrical or unsymmetrical, immaterial to me, they are wrong. Anyone can able to give what is the answer behind it? For flat vane you gave it as a correct, but why you are not going to consider for symmetrical or unsymmetrical of station moving vanes, sir? Anyone can able to guess what it is going to be the right answer? Very simple, my dear friends. If it is a flat vane, if it is a flat vane, the velocity of the jet is going to be, I am going to mention it as v. But once by the time whenever it comes to here, the plate can able to move to some distance, therefore it is moving with u distance, u velocity. Therefore its effective velocity hit the vane is going to be v minus u. It can able to hit the vane with relative velocity. Relative velocity. Relative velocity. Okay, theta is 0 in case of this particular. In this case, theta is 0, I will accept. But I said even though theta is 0, I mentioned it as wrong. But here in this case, theta is not equal to 0, I mentioned it as wrong. Only the reason is, sir, if you observe, if v and u are in the same direction, v and u are in same direction, then relative velocity Vr is always v minus u, is always equal to v minus u. Is it clear? But once if it is a vanes, if it is going to be like this, V is in this direction, U is in this direction. V is in this direction with some angle, U is moving in the horizontal direction. Therefore, what will happen, sir? Velocity. Then what will happen, sir? It can able to enter. It can able to enter into the vane not with V, not with U. It can able to enter with relative velocity. Then how we have to find out the relative velocity? So the V component, the jet velocity, is going to divide into two, sir. So due to the motion of the vane, it is going to be U, and the entrance is not going to be U, it is going to be relative velocity VR. Relative velocity VR. So we have to know this angle alpha. So this is alpha, sir. Sir, how we can able to get the relative velocity of entrance? Up to this it is clear to all of you, my dear friends. Just you tell me, then I can able to proceed, or I can able to explain some more elaboratedly. Some more elaborated fashion I can able to explain. Anyone? Try to give the information in the chat box, I can able to know it. If you can't able to understand this, I can able to explain once again. Okay, Vignesh, some more people please. Good. Now I hope you are already aware of it. What is the necessity of velocity triangle? Good. So that is why if you observe Pelton turbine, if you observe the Pelton turbine, it is a double hemispherical vane. Then you can able to observe the things like this. You go through it, they will show it is V1, entrance is going to be considered as suffix 1, exit is going to consider as suffix 2. That is the notation we are going to consider. They will give it as U, because for Pelton turbine, U1 is equal to U2 is equal to U. That's why I wrote it as U. So absolute velocity is going to divide it into relative velocity and vane velocity. Combination of these two can able to get the absolute velocity. Okay, here V1 is the absolute velocity, U is going to be the vane velocity, therefore it is going to be U, and it is going to be VR1. So whenever it leaves with an angle of phi, normally they gave it as a bucket angle phi. So whenever it comes, the relative component can able to make VR2, and it is going to be phi, and here we are going to write U, and this is going to be V2. So here jet at exit is making some angle and vane is moving in some other direction. That's why we are going to consider as velocity triangle at exit only. Whereas at inlet we won't have velocity triangle. Remember, my dear friends, at inlet we won't get the velocity triangle. In exit only we can able to get the velocity triangle. Is it clear to all of you? What is the necessity of velocity triangles is clear. If the jet entrance angle and vane angle are different, then we are going to construct the velocity triangles. We have to construct the velocity triangles. Now I will consider one particular thing. How the velocity triangles I will explain. Now let us consider the jet is entering at the center, and sorry, not at the center, it is enters at the tip. Therefore this is going to be theta and it is going to be phi. Once if you mention like this, the jet will enters at this position, okay, and leaves from here. Therefore how we have to construct it, sir? Sir, in order to have the shockless flow, it should enter at VR1. So it should make an angle of theta. Sir, in order to enter the jet at theta angle, so the V should not be theta, it should be more than that, sorry, less than that. So it is going to be alpha. Is it clear? And jet is going to leave with an angle of phi, Vane angle only. But if it is going to be u here, u1 or u2, it depends on the problem. If it is going to be u1 and it is going to be u2, then it can able to comes out with v2 and it is going to be considered as phi. These here you have to remember one more point, alpha comma beta, but alpha is most important. So what is alpha, sir? What is alpha? Alpha is called nozzle angle or guide vane. One second, my dear friends, one second here. So remember, here I made a small error here. It is not guide vane angle. It is going to be the runner vane angle. Runner vane angle, and it is going to be the alpha is going to be the guide vane angle. Guide vane angle, or it is also called jet inlet angle. Jet inlet angle. These are the three words we are going to use for alpha. Is it clear to all of you? Alpha is the guide vane angle. All of you remember, my dear friends. All of you, again I am going to give what are the different names for alpha. Alpha is going to be considered as jet inlet angle or nozzle angle. Nozzle angle, or because this is going to be considered for impulse turbines. It is going to be considered for impulse turbine, whereas this can be considered as guide vane angle. In case of reaction turbines, this is going to be in case of reaction turbines. And what about theta comma phi? That is the same, sir. Theta is going to be runner vane angle at inlet, and phi is going to be runner vane angle at exit. So the formulas and derivations we will discuss on some other day. Still, if you have any doubts, try to mention in the chat box. I can able to go ahead with these. Is clear? And V1 is going to be the absolute velocity at inlet. V2 is going to be the absolute velocity at exit. V1 and V2 are absolute velocities at inlet and exit, respectively. Is it clear, my dear friends? Still, if you have any doubts, try to type it here. I can able to discuss those points. Okay, I will give Salahuddin. What is the difference between horizontal and vertical turbines? I will give the answer for that. So, very simple. If it is a horizontal turbine, the turbine shaft is going to be placed on a journal bearing. Turbine shaft is going to be placed on the journal bearing. Sir, if it is a model, the weight will be less. We can able to bear it. Once it is a prototype, means actual power in the power plants, the shaft itself, it is almost a room size, almost 4 to 5 meters diameter will be there, even more than that will be there. If that much huge shaft, if you want to hold it, it is not possible. It is not possible with the journal bearing, because due to this weight, the oil is going to be placed in the bearing will be comes out, therefore solid will contact will come, and journal bearing will lost, means it is going to fail quickly. That is why we are going to use horizontal turbines in the labs and models only. But whereas vertical type, prototype, vertical may also use in the lab, sir, but prototype means power plants. In power plants only vertical turbines will be used. Is it clear? Once it is a vertical turbine, once it is a vertical turbine like this, then what will happen is total load is not necessary to bear it. So in between that I will place a high pressure servo oils, then they can able to maintain some gap, so the rotation will be easy. Or I can able to use the collar bearings. Collar bearings can able to bear more load than journal bearings. So in order to, whenever it is a vertical shaft, huge weight is there, then we are going to use a vertical shaft, and we are going to place with the help of, we can able to keep it with the equilibrium with the help of footstep bearing. Why we are going to use this? Footstep bearing will be used to bear the heavy loads. So here we have to use journal bearings. So that is why whenever it is a model or in the labs, we are going to use horizontal turbines. Even in some labs, vertical turbines also present, sir. There also they are going to place with the help of journal bearings. But once it is a prototype in power plants, horizontal turbine you won't observe. You observe many of the cases, all the cases, you won't get horizontal turbine. There always it is vertical turbine. Once it is a vertical turbine, then automatically footstep bearing will be used, which can able to bear the more load. That's why we are going to use vertical shaft turbine, or vertical turbines will be used in power plants, whereas in these we are going to use horizontal. I am talking about hydro. I am talking about hydro. I will give one more thing. In thermal, that is steam. In steam power plant, remember, in steam power plant, no, whatever the turbine it may be, whatever the turbine it may be, in power plants they are going to use this. In the labs only you can able to observe both horizontal and vertical, but in the power plants is always vertical. So if you observe the thermal power plants, torque and speed, in case of this, torque will be less, speed will be more. Whereas in hydro power plants, torque will be more, speed will be less. So once the torque is, if torque is high, shaft size is high. So once the torque is less, shaft size is less. So in thermal power plant, shaft is not very large in diameter. We can able to bear it on the journal bearings. Once it is a hydro power plants, torque will be very high, speed will be very less. That is why, so it is having a very huge size shaft. That's why in order to bear this, they are going to use footstep bearing with shaft as vertical. Is it clear? Is it clear? Still, if you have any doubts, try to post it on the chat box. I can able to explain some more. Still, if you have the doubts, you can able to make it on the comment box after completing this class. And try to like this video, share it, and subscribe this particular YouTube channel. Thank you very much. If you have any doubts, I can able to clarify your doubts. Thank you, my dear friends.